it's much more common for a researcher to be interested in the difference between means than in the specific values of the means themselves. This video covers how to test for differences between means from two separate groups of subjects. In practice, consumers could be interested in the difference in average running cost for different vehicles. New graduates could be interested in the difference of salaries between different companies. And executives could be interested in the different performance of managers, and so on. Typically, there could be some difference between any given two different samples. The purpose of hypothesis testing is to verify whether the difference between the samples is big enough or significant enough, so the chance of the difference coming from pure sampling error is small. Recall that the test statistics follows the standard normal distribution when the population standard deviations are known. There are three typical types of non-hypothesis. The first one is called one-tail, lower tail. The corresponding non-hypothesis is mu1 minus mu2 larger than or equal to d sub 0. The second one is one-tailed upper tail. The non-hypothesis is mu1 minus mu2 less than or equal to d sub 0. And the third one is two-tailed. The non-hypothesis is mu1 minus mu2 equal d sub 0. In many cases, the value of d sub 0 is set to be 0. In any of these three different hypothesis tests, one-tailed lower tail, one-tailed upper tail, or two-tailed, the test statistic is the same, which is given by z equal to x sub 1 bar minus x sub 2 bar minus d sub 0 over square root of sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. To use this z statistic, there are several additional requirements. The first one is the two populations follow normal distributions. Second, the samples are from independent, unrelated populations. Third, the population standard deviations are known. As we know, these requirements are relatively strong. In practice, t-test is a more popular approach used to determine whether there is a significant difference between the means of two groups. If the standard deviations are unknown, we cannot use the z statistic anymore. Instead, we use the t statistic. Nevertheless, we have the same non-hypothesis in the three different tail tests, namely the lower tail, one-tail test, the upper tail, one-tailed test, and two-tail test. A t-test is a type of inferential statistic used to determine if there's a significant difference between the means of two groups when the standard deviations are unknown and the standard deviations are the same. In this situation, the pool variance is given by s sub p squared equal to n sub 1 minus 1 times s sub 1 squared plus n sub 2 minus 1 times s sub 2 squared over n sub 1 minus 1 plus n sub 2 minus 1. The test statistic is given by t stat equal to x sub 1 bar minus x sub 2 bar minus parenthesis mu sub 1 minus mu sub 2 parenthesis over square root of capital S sub p squared times parenthesis 1 over n sub 1 plus 1 over n sub 2 parenthesis, where the degrees of freedom is given by n sub 1 plus n sub 2 minus 2. As we can tell, these equations are complicated. When the standard deviations are not equal, the equations are even longer. Due to the complexity of these statistics, we do not require using these equations in the quizzes and the final examination, but we will next demonstrate how to use software such as Excel to conduct some of these hypothesis tests for two means as follows. It is worth noting that you are expected to know how to use Excel to run the hypothesis test for difference of means. In the following case study, we are going to assume unknown standard deviations and unequal variances. Now, we are going to demonstrate how to use Excel to conduct the hypothesis test for the difference of two means. In this case, there are two samples about female and male salaries. We first use histogram to illustrate the salary distribution of the two groups. One question is there salary discrimination? In Excel, we will go to data at first and then go to data analysis and get the t-test. Specifically, we select the t-test to sample assuming unequal variances to conduct the hypothesis testing. To examine whether there exists salary discrimination, we have the null hypothesis H sub 0. Average male salary minus average female salary is equal to 0, which is a two-tailed test. From the Excel result, we find that the t-critical value of the two-tailed test is 2.01. Considering this is a two-tailed test, the other critical value is negative 2.01. The t-stat is negative 4.09. Because t-stat value of negative 4.09 is smaller than the critical value of negative 4.01, we reject the null hypothesis H sub 0. Symmetrically, given that this is a two-tailed test, we can also use the absolute value of negative 4.09, that is 4.09, to compare with 2.01 and draw the same conclusion. In conclusion, based on the given samples, there's a significant difference between the female and male salaries. Now, please let us demonstrate the above process in Excel. Please pause here and to open the Excel file and follow me on the procedure step by step. This is the Excel file I mentioned and opened from the PPT slides. As you can see, we have two different samples here. One is female salary, the other one is male salary. And this is the data for female salary, the other one is the male data. In this Excel file, I got some descriptive statistics using the Excel software, but this information are not needed for our hypothesis test. So you can ignore these outcomes. And the key will be on this table. We are going to generate a similar table today. But as I say that we already follow the steps data analysis, and t-test to get this information. Okay, and actually this information is the same as I presented in the PP slides. So let's show how to get the same data information from Excel. You can go to the data, and I believe you have already installed the data analysis, and you click on there. And here, actually, in the bottom 4, you can see 4 different types of hypothesis tests. And we talk about the z-test, we talk about the t-test, 2 samples assuming equal variance. But today, as I shown for the female male salaries, we assume unequal variances. So we are going to use a t-test, 2 sample assuming unequal variances. And we say, okay. And here, the first one is the variance 1, variable 1 range. So I'm going to click on there. And you are going to select, you can include the label, the female salary, and select all the data of the female salary. And you say, okay. Here, we are going to input the data from male salary, and you say, okay. Our hypothesis test is to test the difference of these 2 salaries to be 0. So we put 0. If in case your test is to see a gap between them, you can see, for example, suppose you are going to test the gap is above 100, you can put 100. Otherwise, in this case, we put 0. And because I include the labels of female salary and male salary in my data, so you click on the labels here. Our level of significance is 0.05. Again, you can change it based on your need. And you may have different kinds of output choices here. And I'm going to demonstrate the output range directly, probably just here, so that you can see it clearly from my output on the same page. So I'm going to say, okay. But again, before I click on OK, I'm going to repeat the process. You put variable 1, variable 2 here, put the difference of the mu1, mu2, and put labels, level of significance, and the output. Okay, I'm going to click on that, and you're going to see the output of that. If you kind of slightly change the gap of the first column, and you see that actually these are exactly the same value as I just got previously, right? So this will be the T critical value will be 2.01, and the T stat is negative 4.08. As I said, this is 2-tiered test, and the T stat here is outside the range of negative 2.01 and 2.01. And so this T stat is in the rejection region. So we know that we are going to reject the null hypothesis. Also, from the p-value perspective, we know that the p-value is very small, right? It's 0.0001. This definitely is smaller than the 0.05 level of significance. So if we are going to use p-value test, we can also use this to tell that the null hypothesis is rejected. And so that we have sufficient evidence to claim that the female salary is significant difference from the male salary. Okay, so in this video, we briefly show the z-test for the hypothesis test about mean difference when the standard deviation are known, and the t-test when the standard deviation are unknown but assumed to be the same. Finally, we use Excel to demonstrate the hypothesis test about mean difference when the standard deviations are unknown and the variances are unequal. In practice, Actually, the last hypothesis test is quite often, because most of the time we don't know the standard deviation, and definitely we are not very sure whether the variances are equal or not. Anyhow, it is important to practice Excel to fully understand how to conduct the hypothesis testing.